Hi, Nirmal. Can you hear me?
Yes, sir. I can hear you.
Nirmal, you can share your screen and I'll give a small introduction in a little while and we can start off.
Oh, sure.
Hi, everyone. We'll be taking a few more minutes. There are still people joining in. And yeah, in a few minutes, we'll be starting off soon. Hi everyone. Good afternoon, and thank you for joining the eighth session of the Podium Tech Talk series organized by Asera Digital Labs. The main purpose behind putting together a series of interactive and knowledgeable webinar is to enlighten you all on the latest trends in world of digital transformation and how Asera Digital Labs provides services that accelerate the global digital adoption of business around the world. So we warmly like to welcome your speaker for today's session, Nirmal Hasantha, who is a qualified cloud engineer at ADL, who is working with businesses helping to deliver seamless experience in their cloud journey. And a little bit about Nirmal, he is an experienced cloud engineer at the lab who holds a bachelor's degree in electronic and telecommunication engineering from Sir John Kotalala Defense University, Ratmalan. He's also a Huawei certified ICT associate, Cisco certified CyberOps associate, AWS certified solutions architect, and also Cisco certified network associate. So a little bit about today's event. The topic is Introduction to Video Streaming on AWS Cloud. And today's speaker, Nirmal, will touch on some main topics such as what is video streaming, how it works, why we why can't we all be streamers, solutions, how cloud solves problems, and also a demonstration. Uh, Once again, thank you for joining. So without further ado, I'll hand over the session to Nirmal. Nirmal, if you're ready, over to you.
Yeah, sure. Thank you, San. Good afternoon, guys. So today I'm going to give you basically an intro to cloud video streaming, more specifically an AWS-based cloud streaming. So let's cut to the chase and reiterate the content that San just mentioned. So first, I'm going to start with the very definition of video streaming, like what is the technical definition, what is in general video streaming means, and then I'm going to explain the network infrastructure, the backend network, how this video streaming works at the packet level, kind of explanation. Then, why do we have to rely on third-party servers or third-party techniques in order to do streaming? Why can't we, as home users, why can't we stream without relying on such technologies? And finally, what are the solutions that we can offer for that specific scenario? And how cloud step into this particular game and try to solve those problems into some extent, and how it has been solved, these questions, all these years until now. Started from very recently, of course. And finally, a live demonstration, a live video stream from my on-premises computer to AWS Cloud, and a VOD sort of video streaming. There are two different categories. I'll explain on the way. Yes, guys, so let's start with the very definition. What is video streaming? What is audio/video streaming? So there are many definitions you can get, especially that is combined with the bandwidth of the network and the data packet itself. But in more general, it is as follows: a burst of packets that are sent from server to client or from peer to another peer, where those particular end users can access that data packets effectively at the middle of data transfer. What that's supposed to mean and how it is different from downloading a video file. Now let's say you're downloading a video file from 123 movies, right? So can you interact with that particular video file amidst of the downloading? If you double click the particular video file at the middle of the downloading, when all those fragments are not yet been copied or downloaded into that your computer, it most probably tell you that file is corrupted or it can be opened until the downloading is completed. But if you just click on a YouTube video, the moment you click it, right, just after less than a second, you can not only interact with those data packets, which you can, in general words, you can listen to those audios and you can watch that particular videos, right? So that is the main difference, guys. That is the line between downloading and streaming. It's all about the interaction, effective interaction, as I mentioned before. You can't effectively interact the data packets of a regular download, but in video streaming, that is the definition itself. You can effectively interact with those data packets, because at the end of the day, all of them are data packets in a data packet network. In order to further elaborate, let me get this diagram. So, shows the pen in here, and here, assume this is you. Okay, this is your home computer in here, or your office computer, anyways. This is you, and you need to do a video streaming. You need to do a live video transmission. But the thing is, your friend over here need to access that particular stream at the same time through the public internet. But instead of making a direct peering connection, a peer-to-peer connection, a one-to-one peering connection between you and your friend, what you do is you send all your information, your desktop sharing information, your audio and video to this middle server here, which in this case named as the streaming server. Instead of a peering connection, now you have a client server connection. And likewise, if your friend need to access that particular stream, he has to do the same thing. Instead of making peering connection directly with you, which is not only fast and more reliable, and then the backend network infrastructure is much capable of doing such a thing, it has to rely on a client server connection again. Why is that? And it's happening right now, guys. My information, my desktop share information, my audio and video, it goes to one of those nearest Microsoft Teams server. Assuming there's no Microsoft servers in the Sri Lanka, the nearest must one be at the India or Singapore. So my data has to travel all the way through to that particular location, and you guys have to do the same thing. You guys have to access that particular stream by connecting all the way through that server in the Singapore or India, because in Sri Lanka we don't have really dedicated servers, especially in Microsoft. So why that rush when those dedicated network protocols inside those routers and switches inside this internet network can make a perfect peering connection? It doesn't have to be one-to-one. It could be one-to-many. It doesn't matter, because those, as I mentioned before, they are perfectly capable of doing such a interaction. But why? Why do you have to basically depend on such a technique? And it's not only stops there actually. Every time when you do a live YouTube, if you go to YouTube live or you go to Facebook or Instagram live, what you do is you practically send all your information, your video information, audio information to that particular Facebook or YouTube server. Why do you have to rely on such a thing? That is actually affecting to those performance drastically, guys. We might not see it at the moment because we're doing it, and this system has so much optimized. I give credit for that. But why do we have to send all this data to the nearest location all the way through, maybe they're out of the country, in order to do such a simple data transaction? The answer to that is because of the address translation. So if this address translation, or more precisely the network address translation, is the very technique that keeping us from being free streamers other than rely on those particular servers, why don't we just kick this out of the system? Well, my friends, 95% of you here can't even access the internet. Forget streaming, guys. Can't even access the internet without this very technique right now. Because in late 70s, when the fourth version of internet protocol has been introduced, which generally known as IPv4, which is a technique that is used to distinguish each user from each other when they access the internet, right? When that protocol has been introduced, they have never assumed this much of user growth. So that particular IPv4, the way that they distinguish each user from the internet is by assigning them a 32-bit address. So how many possible address combination that can we get out of 32-bit address? Each bit can be 0 or 1, right? So it's 2 to the power 32, which gives us around 4.3 billion public IP addresses. But the thing is, at the end of the 2020, IoT devices alone are about 9.7 billion. So it's double the value of the addresses that we can offer. So if you're trying to basically assign each device address by address, out of those 4.3 billion IP addresses, we're never going to satisfy the demand. And the worst case scenario, out of those 4.3 billion IP addresses, we can only use around 3.7 billion IP addresses, because those the rest of the 0.5 billion IP addresses are reserved, and most of them used as for research purposes, and some of them, a subset of that, is used as private IP addresses. What's a private IP address? Well, every time you log into your home router, it would be 192.168.1. something, right? And more conveniently, every time when you go to your friend's house and try to do the same thing, most of the time it may be the same address, 192.168.1, to access the home router. Now we have a dilemma here, right? If you think now having same address but they can access the internet, how the internet know to distinguish you from your friend? So in that case, that IP address, that private IP address, somehow need to be mapped to one of those 3.7 billion IP addresses which are known as public IP addresses. It could be mapped, or in other words, it need to be translated to one of those public IP addresses, guys. So that is basically what NAT stands for. That is how it works. The network address translation is a technique that is introduced for the scarcity of the IP addresses that most of us that we use today, the 4th version of IP addresses. Let's try a demonstration, shall we? Like a example of trying to do data communication just by using the NAT itself. No other technique, just NAT. Okay, now imagine there is a server here. Let's say this server, for the simplicity's sake, let's say this is equipped with a public IP address. Now there's no NAT configurations going on whatsoever. This particular computer in here need to access this server. So first, this switch here, it maps 192.168.1.2. I'm just, for the simplicity's sake, I won't write this part, to this public IP address over here, which is 202 blah 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 something. And when that happens, when the packet is generated, the source IP address would be the IP address of the public IP address. So because as I mentioned before, you can't access the internet without the by using private IP addresses. And also, what would be the destination IP address? Destination IP address would be the IP address of this particular server is trying to interact. So now no rules are violated, even though the translation happened. No rules or protocols of the IPv4 itself has been violated. So packet goes smoothly to this. Let's say this is a web server at USA here, and then the server replies back. When server replies back, let's choose another color. That packet would be as follows. So source IP address would be the IP address of the server. The destination IP address would be this one, because it has no idea about this N network, it only know about this one. So the destination IP address would be this 202 something, and this would be its data. So when this packet came to this particular network, it has a mapping, right? So within this switch, it has the mapping 192.168.1.2 has been mapped to this particular IP address. If we reverse that mapping, the switch can simply send out the packet to the packet out of the relevant switch port. So everything is solved, right? Or is it? Now this is a single scenario, guys. This is only this happens, this particular scenario happens, only one device is trying to access the internet. But what if the same server need to be accessed by 2 devices at the same time? It doesn't have to be the same server, but let's say the 2 devices try to access the internet at the same time. For the simplicity's sake, I'm using the same server. So the previous functionality again happens for the both of time. The server has no idea about this N network. It replies back, and the replies are as follows. For this particular computer, the source IP address would be the IP address of the server itself. The destination IP address would be this, and the source port will be most probably port 80, since we assume this is a web server. And for this particular one, again, the source IP address would be the IP address of the server, and the destination IP address would be IP address of this particular public IP address, and the port IP address would be 80. Now there are 2 entries in this switch. One is when it's translated this computer's information, basically 1.2 has been translated to this particular 202.45.1.1, and also 192.168.1.3 has also been translated to this particular address. So how the mapping will be reversed? If the mapping is reversed, it will be reversed to 2 different addresses, right? So if that happens, the switch it gets confused, right? Just like I did, it gets confused, and it has 2 choices. Either this switch has to forward all these likewise traffic in this kind of functionality out of all its switch ports, because if the mapping has been reversed, it will map to 2 different addresses, and this is actually a simple scenario. Worst case scenario, it will be mapped to thousands or maybe a tens of 15s of addresses, not thousands actually. And if the functionality is reversed, it would be to the same. Switch has 2 options, as I mentioned before. It either can flood its ports by sending all this traffic into or out of all its ports. So in that case, only the relevant traffic will be chosen by this computer kind of logic. Or the most justification action, it actually drops all of these packets. If we use NAT alone to do simultaneous communication in order to address the scarcity of IP address, which keeps us from being free streamers, this technique dies, guys. Like there's no way to do this if we just use NAT. So what is the option? Well, as I mentioned before, this happens when this computer has been distinguished by its IP address, regardless whether it's public or private. So instead, we use another tag to distinguish this computer from each other. Like 192.168.1.2 and is tag 1, 192.168.1.3 and is tag 2, and the switch itself will translate like this: 192.168 blah blah blah. 1.2 will be translated to this particular address along with its tag, and also 192.168.1.3 will be translated to the same address but along with its tag. What are those tags in here? How to distinguish each computer? Like, now again guys, we can't break the rules of IP addresses, right? We can't suddenly insert a tagging slot into the header of the IP packet itself. We can't do that. We have to play the games by rules. So how this distinguish can still be happen? How to do the simultaneous data transfer? How to do the streaming? Well, guys, this tag, they have chosen one of those dynamic port numbers out there in order to distinguish computer alongside with its IP address. What are dynamic ports? So I'm pretty sure you heard about this port, right? I mentioned it before. Port 80. This is actually the web port. And also port 25. This is SMTP, Simple Mail Transfer Protocol, as it sounds. Port 53 for DNS. Now guys, these are standard ports. But out of 1 to a certain level, these are standard ports. But there are another kind of ports, just like private IP addresses, that are unused, which are known as dynamic ports. The range starts from 49,100 and something, I can't exactly remember, it goes to 65,535. 535, sorry about my handwriting. Yeah, so this is a really large range, and you will straight away find for single local area network, this is more than enough, because more than 15,000 dynamic ports are available, and the switch makes sure not to assign the same dynamic port for each communication. So when that happens, with the tag alone, if we consider that previous situation with the external server, when the two packets come here, now we have to consider the 4 of the slots: source IP, source port, destination IP, destination port. So when two of these separate devices try to access the internet, in the sense try to access the same server, the source IP, the replies from this server for this particular network, the source IP would be identical because it would be the IP address of the server itself. The destination IP address would be the IP address of this particular NAT router. So that is identical. Source port, we accessing the port 80 here, right? Because assuming this is a web server, so that would be identical too. But the destination port, that entry that is saved in the switch, will be different. From that point onward, guys, the distinguish can be made, and it will be sent out from the correct switch port. These switch ports are not the dynamic ports. If you just confused, these switch ports are actually those LAN 1, LAN 2, LAN 3 ports kind of things that you find on your home route as well. So you don't have to worry about it. So that is it, guys. That is how this entire problem has been solved thanks to PAT, port address translation. We basically use a port to do such thing. But again, sorry about that, we're not actually in the port. We use port, of course, we use the port translation in order to address this particular issue. But for the simplicity's sake, as I mentioned before, I assume this particular service is equipped with a public IP address. What if it's not? Now, we are trying to be free streamers here, right? So in that case, this would most probably be your friend, not a public IP address. So your friend has the exact same setup as this. So what happens? It has a NAT device, a switch, and it has its own computers or devices and local area network. If you try to live stream to your friend, how the packets will be named, how those IP headers will be assigned. Source IP address would be the IP address of yours. Destination IP address would be the public IP address of your friend, which can be easily found. Source port, let's say you are addressing one of his dynamic ports here, and the destination port would be one of his dynamic ports, and the source port will be one of your dynamic ports as well. So it's no issue. We're not addressing web server here. So let's say it's some sort of a application. Let's say it's a game you try to play, GTA or something. But the thing is that when this particular packet came to this particular switch in here, this switch has no mapping information previously whatsoever. If this particular source IP and source port has been reached, where to send those addresses, right? Because unless otherwise we not pre-configured those settings into the switch, which is known as the pad itself, this switch has no idea where to send those packets, because suddenly the switch will be reached with this IP header. Source IP address I mentioned before would be this. Destination IP address would be his own. Source port will be one of your dynamic ports, and destination IP address destination port will be one of the ports of your friend over here. So without any further pre-configuration of the switch or the mapping itself, the packet will again drop. A technique that is so smooth actually is flip-offs at the very last moment. But as I mentioned before, pre-configured, guys. If we have assigned this switch, we configure this switch, okay, switch, if you found any data that is come from this particular source IP and source port, this combination, send it to my LAN 2 port. Right? If this combination has been given, then it's fine, guys. Then you and your friend can successfully communicate with data. Actually, that is what called the port address translation. You translate your port by assigning it as a mapping into a switch itself. So by doing so, actually we have solved almost all the problems that has been given by the fourth version of IP protocol, which is known as IPv4. The reason this is known as an address translation is because when, let's say, the 192.168.1.2 has been, along with its dynamic port number, let's say 49,125, is being translated to this particular public IP address. This NAT device over here, it again does such mapping. It again map it. Now this address can't be used for the access of internet, so it will be 202.4.1.1 something colon another dynamic port number. So that information will be saved with the NAT device, but we don't have to worry about it. Like I'm telling you about an overall story. Now guys, after that one, we can wholeheartedly do video streaming from end to end without any problem. The IP addresses won't be an issue anymore, so everything looks fine. Okay, now let's go for the next one, which is the very technique I have explained it a bit. So the port forwarding is actually what saved us. The NAT itself can't actually do much, as you see. There are many downsides on that, but port forwarding, even though with the pre-configuration as such, could be done. So in definition, it basically allows remote computers in LANs to communicate with each other. This is the very definition itself. So it's not, the video streaming is not magic by any means, even though we use cloud, if we understand this network configuration behind it. Okay, in conclusion, now let's watch about what are the obstacles we had so far. We were lack of public IP addresses, with the main reason we had to go through all that trouble, which even we can't access the internet without that NAT to extent. The NAT, actually doing NAT consumes a lot of computation powers of that switch and routers, guys, because there are maybe that router would be one of those regional routers. So if we have to do many mappings simultaneously, like 10 to 20 mapping simultaneously, it will the CPU utilization surely goes up. So it is actually a drawback. Those packet sending speed will be reduced, the latency will be increased, and the port forwarding is nightmare. This is the thing. If you remember at previous days, if you have a CCTV camera installed at your house, maybe you or your father, you just simply type the public IP address of your house, colon, one of those dynamic port number that is assigned by the CCTV camera, just in a web browser, and immediately you will be flashed with the live CCTV footage, because the CCTV camera backend itself will be configured with an RTSP server, real-time streaming protocol server. It has a small server going on here anyways, at least its backend. But the ISP was like, if we allow this particular thing to happen, people won't purchase public IP addresses from us anymore. So here we go, and they have basically stopped the packet forwarding, this port address translation from this router here. So even though you configured such a mapping prior to the communication, as I mentioned before, from the switch itself, it won't be matter because this router has disabled it. But the actual reason is a bit more complicated, because we are actually using double NAT, and within double NAT it's actually more complicated than netting it 2 times. The network infrastructure is more complex, but due to technical reasons and all, now it has been basically demolished, the very idea of port forwarding. And none of those issues has to be faced we can easily do video streaming end to end if we has IPv6, the sixth version of internet protocol has been introduced. Actually, it has been introduced a long time ago, but the deployment of IPv6 is still under development. The reason for that is, guys, we can't just replace those back-end network infrastructure devices. We have to do firmware upgrades, software upgrades, and all of them. So now it is actually if you do a simple Google search such as what is my IP, and if you find two IP addresses, one is an IPv4, IPv6, you most probably are using IPv6, but most of the time it is tunneled. So as I mentioned before, some of those backend network infrastructure devices are not capable of IPv6. They don't understand the protocol. So what basically happening is that IPv6 packets are encapsulated in an IPv4 header and then send it through those non-IPv6 related routers. That's actually a long story. It has nothing to do with this, but that is actually the network behind the complexity behind it. It is still under development, and if one day this deployment has been completed, this is the result we can get. As I mentioned before, IPv4 address consists of 32 bits, right? So it gives around 4.3 billion IP addresses, 4.2 in this case. But IPv6 consists of 128 bits. If we get the possible combinations in here, to be honest, I don't know how to read this number. It has been said, if every person on the earth has been given billions of devices, every person of the earth has been billion of devices, and each device assigned a IPv6 address, we are still in pair of 4 trillions of IP addresses. That is how much of big this number is, guys. No network address translation, no port forwarding, all these CPU utilization powers, all those latency will be decreased, all those performance will be gained. And if so, if IPv6 has been launched, why do we have to trouble with doing cloud-based video streaming? Like there no need, right? Like if we can, if you want to do a video streaming from you, even regardless from your home or your office to certain clients, you can literally collect their public IP addresses and make a peering connection, one-to-many peering connection, and do that it is. Why do you have to worry about this? Why do you have to send those data to cloud, which is again a client server connection, not peering connection, which add additional latency when it compares. We have to purchase those subscriptions, Zoom, right? We have to pay those subscriptions in order to do that. Where when the IPv6 has been launched, we can do this on a protocol level. The software might not look really nice, but we can make softwares for the front end. That is no problem now. But why all this trouble? Even after IPv6 launch. The reason is, guys, the great power comes with great responsibilities, as you know it. When the IPv6 has been launched, the VPN would be a very common thing, because when you have been given a dedicated address, when your device has been given a dedicated address that could be traced in the internet, and it could be directly targeting not only you but to your specific device, it would be bread and butter to hackers just to get into your computers. It's no joke, right? Because previously we have been using VPN to hide our location. The NAT actually hide that location to a certain extent. Because of the NAT, it translates addresses to many locations. It actually hides it particular location of yours to a certain level, of course. But IPv6 is direct locations in there. You can directly access without any problem if you're a hacker, of course. And your AWS free antivirus will no longer be supported. Like, you need to at least pay for the AWS premium antivirus. You need to have not only software level security, such as those malware and firewall tools, but also maybe you have to go for the hardware level if you're having an on-premises computer that is really mission critical, like IDS, intrusion detection systems, and IPS, intrusion prevention systems. So if you combine all these additional cost and those dangers and all that, you might think the IPv4 is suddenly looking pretty good. So, and also another thing happened in this era. The world is converging into cloud, guys. So they have decided, why do we take such a risk when there's a specific platform out there that is specifically designed to not only compute, not only network itself, but also to store our particular data? Why don't we just send it there? Because now the cloud platforms are really reliable. So that has been said. These are how the cloud saves the day. So yes, it won't be a peering connection, but you won't be able to have a public IP address. Like, you don't need to have public IP addresses regardless of what version of IPv4 you needed. Of course, you need to have an IP address in order to, for the workaround, but you don't have to rely on IPv4, IPv6, it doesn't matter. You just have to pump your data into the cloud. And it is platform independence, guys. Your cloud framework can be accessed even from your tablet, even from your computer, even from your Arduino board, or more probably your Raspberry Pi itself, if you install the right configurations. And as I mentioned before, there are middle servers, right? At the very first example that I have done using Microsoft Teams, there's a middle server. Now, instead of sending data to the middle server, in this case, you theoretically be in the middle server. So that is another advantage. And also, one of those previous problems we had in cloud is that even though we can easily start a virtual machine in there and do all our computation tasks, we can't really input one of those most important cognitions that is known to man, video and audio, because we could find some workaround even for last few years, but they are not effective, guys. They are not optimized to send those video files and audio files that is almost to the same speed as the peering connection. These particular cloud tools that we use today to pump those live video streams or VOD to the cloud are so optimized. They are not only optimized in the data link layer, but also in the application itself. And also, it's a very low latency. Like, you can't distinguish a peering connection from the actual client-server connection in the cloud kind of latency reduction. And it is cheap and reliable. You all know the cloud, if you use the cloud platform correctly, it is very cheap, and the reliability comes as a bonus. And what is the tool? What is this very tool that I'm talking about that can stream video files into cloud? Which is in AWS, it is known as Kinesis Video Stream. So basically, guys, a Kinesis Video Stream is a very lightweight software. It's an SDK, actually, a pre-compiled SDK that can be run not only in your Raspberry Pi, but also in your any high-grade workstation. What it basically does is it collects inputs from all those, let's say, CCTV cameras, your desktop, maybe one of those thermal image-based cameras, yours again, all of them, and it will be sent to AWS directly, where you can use it in your within your computational services. You can use it to do real-time machine learning recognitions. You can use it for SageMakers. You can, as you mentioned, you can use it for various machine kind of workloads. And also, there are many applications. I'll give you a brief idea about it on the upcoming slides. This is basically it, guys. So AWS created a SDK that's going to carve the packets. Now, if you're going to just do video streaming using one of those existing protocols, let's say RTSP, that won't be much effective because the packet might get damaged on the way. And if you want to do a concurrent streaming, there might be jittering and latency. But this SDK carves those packets very smoothly, where the corruptions of the packets are actually near to zero. There are no corruptions whatsoever, and even though there are corruptions, they will be fixed at the 7th layer, not those down layers, which actually decrease the latency. If we try in a regular video stream, let's say if we use RTSP stream to stream data into cloud, somehow there's no direct way to do it. If we do that, this data stream might be corrupted. We have no idea, because no one is going to be responsible for those frame corruptions or frame dropping or anything. But this SDK is specifically designed to rectify those errors, but not in this, but not in your computer. They have immediately sent all those bits and pieces that is been inputted by those CCTV cameras or web camera immediately through this pipeline, which is known as Amazon Kinesis Video Stream pipeline, to AWS. From that point onward, AWS is the one who cares about your frame rectifications, latency adjustment, those avoid jittering. So in that case, AWS is especially this is a very large platform. They have all those techniques to do the rectification and smooth video transmission. So we don't have to worry about that. So this is it, guys. This is basically the AWS kind of way to do live video streaming or video on demand kind of video streaming into the cloud. We can use those streams simultaneously, let's say for the video recognition as well as your machine learning algorithm, or we can directly save this in one of those object storage in cloud. No issue. Like, we don't have to worry about the load balance. Let's say if the same video stream need to be used for several applications as such, We don't have to worry about the load balancing. Likewise, if we're going to do this from scratch at your home or your office location, AWS will take care of it. So that is basically what the Kinesis video stream is, and these are one of those advantages. We could actually stream from many devices as possible. Of course, it is connected to that particular switch or to your SDK. So basically, you can install that particular SDK in your computer and start streaming right away to the cloud, live or VOD. And it's the latency is actually pretty good. Even the nearest data center in AWS is in Mumbai, India, because there's no data center in Sri Lanka in AWS yet. The latency, the maximum latency is around 3 seconds, guys, because we have tested it when we do some certain project. Of course, the bandwidth need to be into some level, but it can be achieved using one of your home 4G routers. There's no problem. And we can successfully do the playbacking and recording, and we can re-record the video stream on the cloud without an issue. And also it's secure. The video stream that is sent from your computer to cloud is end-to-end encrypted. It's actually server-side encrypted, because now imagine a previous situation. Even though we use IPv6, there's no base level encryption whatsoever. So if there's a man-in-the-middle attack is happening, all of your data will be sent away. But in this case, it's not only reliable but also secure. And it's durable, and you know the cloud storage is known as an infinite storage, and you only have to pay per use if you use the correct subscription, of course. And yeah, that's sort of a thing, and you don't have to manage any infrastructure. I'll explain this particular thing later in just using just 2 images in here. So if you remember, if you have a CCTV camera at your home or your office, previously you have to save this into one of those HDDs, right? You have to delete those previous footage every week when it is full. So unless otherwise you copy that footage into something else, it will be completely gone. And you have to maintain, you have to bear those hardware infrastructure costs. Maybe there's special softwares that need to be installed in order to get the stream and download that in a particular manner. Now you don't have to worry about it. Now your streams will be safe. Now instead of making a dedicated computer for that, like let's say it need 1 TB of HDD that is connected to let's say the minimum hardware configuration of Raspberry Pi with a very high memory, and so because he had to do a lot of computation simultaneously, right? But now all you have to do is install a very lightweight software in one of those Raspberry Pi, which maximum need 2 gigs of memory, which does not need external storage or whatsoever in order to install this file. What it does is basically pumping all these video packets into the cloud. Now you don't have to worry about storage or anything. You have to pay for the storage, but the cloud storage, again guys, is really cheap compared to the hardware infrastructure cost that you have to maintain. Like it's 10 times cheap compared to when you have to buy every time when the storage run out. That's the one huge advantage. And if you are a IoT kind of guy, if you constantly send in those thermal images in order to use it for as inputs for one of your machine learning models, but in the cloud, but you were concerned in that how can I send this stream effectively with minimum latency to cloud? Now there's no excuse. Now we have this particular technology where even you can install in your workstation, or as I mentioned before, in your Raspberry Pi, can directly pump those video stream into the cloud, and latency will be maximum 3 seconds. If you have a good connection like the fiber connection, that would be like around 1.5 seconds. So guys, it is optimized. This is the main thing that actually kept those users by avoid using the cloud, because the complaint that we had most is that there's no effective way to send the video stream from cloud. So what they have done is they have purchased those expensive GPU cards, let's say NVIDIA and all, try to build a workstation in here. But if they need upgrade with the current situation of country, even those parts are not even shipped yet. But this kind of high performance computing task can be deployed in cloud within seconds. Those are the advantages of cloud itself. Now, as an additional bonus, the video streaming software dedicated repository for video streaming has also been invented. Now it's a match made in heaven. Now this can be accomplished with zero voice. So those are one of those applications that we can use, but of course use your imagination. Now the video stream can be pumped to cloud. What you can do within the cloud, that's up to you. You can do it for like all your creative works can be accomplished using this. And I'll explain one more technique why this cloud Kinesis video stream, cloud-based video streaming is so good. So one of those techniques that other than using UDP protocols, which is user datagram protocols, in order to optimize this stream, they use a special technique called fragmentation. The reason you will get a SDK is because after the compilation of SDK itself, this SDK knows what's your bandwidth of the computer is, even it's a Raspberry Pi or workstation, whatever. Then it also know what are the capabilities of your NIC card, what are the devices that are connected to your computer, all of them. So after adjusting those values, it instead of taking, now this is a VOD kind of situation, guys. Imagine you have a video file, now you want to send it to the cloud as a streaming service, as a streaming video, just like YouTube and view. So now instead of try to send bits and pieces to cloud without any kind of method, they have methodically fragment that particular video file into certain pieces, where each piece is only around, let's say around 108 bits or 2000 bits. This the how to determine how much this fragment would be, because if this is a 1 GB file, we can either cut it in 100 MB files, right? But whether it is 100 MB files or whether it's 100 MB files or just 500 MB files, that will be determined by the SDK based on these values, based on your NIC capabilities, your network speed, all of that. So this fragmentation is actually pretty intelligent, guys. So you don't have to worry about this. The SDK will figure it out, but also you can manually set those configurations as well. I'll show you in the demo. And those kind of techniques, those kind of chunks will be sent to the video stream. As I mentioned before, in that case, it will be really fast instead of trying to send those to a very large number of fragments to the end device. And the AWS Cloud, I said that they are specifically designed to face this kind of situation and readjust those files into its correct position and give you the final outcome within seconds. And one thing to realize, guys, now this is a relatively new service, AWS Kinesis Video Stream. So right now it's only about H.264, H.265 encoding. The codec for the video streaming and for the audio streaming is AAC. But of course, in the upcoming sessions, one of my colleagues will explain you. There's a workaround for this one. There's a very small workaround actually, not to worry about much. How to overcome that issue too. Yeah, that's about it, guys. Now let's quickly go to the demo itself. So for the demo, I have used my Ubuntu VM here. So I mentioned before that you need to have an SDK, right? You need to download an SDK in order to do this. So the SDK, sorry about this, yeah. The SDK can be downloaded in here. So simply do a Google search, AWS Kinesis Video Stream SDK, and you will pop up with this one. But this is not pre-compiled, guys. The reason for that is that aforementioned facts, like this SDK has to figure out what's your network bandwidth and all of these things. So if it's pre-compiled, we can't do it now. So after downloading this one, you have to go to certain compilation processes and insert certain commands in order to just do the compilation. It will be easy. It will be really easy to understand. I'll also post one of my custom-made scripts in order for you to try it at home. So it will be really easy. I highly recommend you to use an Linux operating system. I'll give all these links. Don't worry. I'll try to. The reason for that is in the Windows one, we have some conflicts with the developer libraries, because if we use Windows environment, we have to install those Visual Studio 2015 or above one, which have a conflict of its own libraries. So I would recommend to use an Ubuntu or any Linux environment, and also try to run this on a virtual machine, so it won't affect to your computer that much if you're going to use this as a test one. So that's about it, guys. After downloading the SDK and compilation, you will be reached to this particular repo. This is the repo, and this will be the sample video that I will try to send to the cloud, both audio and video. And I have created some custom scripts, as I mentioned before, for the video uploading, like the video VOD kind of video streaming, and for the live video streaming. These are the steps. Open it. Yes, first, so I don't have to explain this to you, like you will figure out easily. But first, of course, you have to go into the repository and export these several commands in here. So the first one will be related to the SDK itself, or the second make sure this entry is here, because unless otherwise, if you don't have this particular entry, the video will be exported to the default AWS region, which is in USA. So we need to find out the nearest data center. AP South 1 means that is in the Mumbai, India. So we don't have to send our data all the way up to USA now. So that is about it. And insert your AWS access key. It's pretty secure, as I mentioned before. It is end-to-end encrypted, and also in order to distinguish what's where to send what, you have to generate an access key and secret key, and use the sample file in here. Then use this one as the name. This is the name of the pipeline, guys. So I'll explain it. And this is the name of the video itself. In this case, video name before is this particular video. And let's see, right? First of all, you have to create an AWS account. After doing so, within this search bar, search for Kinesis video stream. And select the video stream and click on create. Now let's give it a name. The name need to be identical to this one, ADL demo, because that is the name. So you can give any name you want, and that name need to be same as this one. I'm going the ADL demo again, and here you can see the encryption KMS custom managed key. KMS is actually key management service in AWS for the encryption purposes. I'm using the default encryption, which is symmetric. Creating the demo. Now its ADL demo is here. So if you look into this sample media playback, right now we won't find any media because nothing is uploading yet. Okay, let's see by running this script. Now this is the exact same script, guys, but the thing is that my AWS credential will be there, so I can't really open that file, but the same thing. And immediately it started to send chunks. If you just look at it here, these are the chunks that the OS has been figured out. So you can see it has immediately started. Let's just refresh the screen. I'm assuming you can hear the sound. Sorry, there might be a jittering because I'm doing 2 simultaneous video streaming, one to you, one to AWS. So let's give it some time. Going to the very back. Started.
The ocean floor rises 5 miles to the shores of what people call the 7-mile miracle.
So you can see the streaming is really smooth, and the sound is really crispy. The resolution is as the video file.
What would it be like to be born?
Even I'm doing multiple streaming at the moment, it works out pretty good.
To grow up on these shores.
Now you can use this particular link if you use in AWS itself. You can actually use this particular name also, ADL demo. But if you, let's say you want to use this particular stream for other purposes, let's say something at your GCP cloud or something, in that case you have to generate an HLS link. Otherwise, if you use the AWS Kinesis video stream, you are doing your computation in AWS, so you can actually work with this ARN itself or this pipeline name itself. No problem. And also you can generate a dedicated HLS link. HLS stands for HTTP live streaming link. If you distribute it, anyone can actually watch this particular stream. Now this is only a sample.
To witness this water every day.
Let's see how to do it. So this is actually in the AWS sample. This is specifically designed for that one. Now in order to view this HLS, you need to have a specific media player. I've tried it with VLC. VLC said it's supported, but it's actually not. So if you have an HLS media player, this is actually, you can find it free. Like if you just search free HLS media players, you can immediately find one. Yeah, that's about it. So that's about the VOD kind of video streaming, guys. Now, as you can see, it has already been completed. Even though the file size is around 275. So let's do the live video streaming, which is actually the very last of our presentation. You just simply have to drag this. I'll explain the script itself first. In here, guys, as you can see, the attributes might be a little longer. Yep. Attributes might be a little longer, but of course, the export default region will be the same, because you can do any changes. Like you can adjust the bit rate, the bit frame rates here. You can adjust the frame rate of the live video stream. You can adjust the bit rate. You can do any attribute configuration whatsoever as to your preference. But keep in mind, if we do not specify those values, they will go with the standard or the most suitable values to your computer. But in this case, I have specified it anyways because I was confident, but not sure about that now. Insert your AWS access key and secret key and choose your location. Again, this is not necessary actually. I just did it for the simplicity sake. That's about it, guys. Okay, now let's do the video streaming. I'm dragging and dropping this one. Prior to that done, we have to create another stream, right? So let's create a video stream. I'm naming it as ADL demo live. Encryption is now the same. Let's see, there's no media right now in the sample media playback. Let's just drag and drop the file and enter. Now immediately after, my webcam will be turned on. Yeah, that is me. That's about it. That's my room actually. It's such a mess, don't worry about it. Yeah guys, so you can see the latency is around 3 seconds. It is still happening. Every time the fragment will be sent, which is optimized by the SDK itself. And let's see how much of latency we have. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, 6-second latency because I'm doing multiple video streaming right now. But that's not a problem. So you can see the playback is really fast. There's no need to worry about that one. So if this is fast in here, it will be definitely fast in those other sources as well. So let's use this Kinesis video stream media player where you can generate a publicly distributable HLS link. I have already inserted my secret key. I will rename this as ADL demo live. You can set this to expire after a certain time. The maximum you can pull is around 12 hours. And when I click on this one, it will immediately launch the same footage. But now you have this dedicated URL where you can share with your friends if you do such a video streaming, live streaming, regardless, it doesn't matter. And if you try to play this with one of those HLS media players, I'm gonna paste that here. Let's play it. See, I'll be there again. So that is about it, guys. So you can use this technique, you can use this cloud-based video streaming to any of your applications. All those previous questions and previous drawbacks that is related to this particular video streaming has been solved thanks to this particular SDK and the AWS itself. So that's about it, guys. Thank you very much for joining. And if you have any questions, please go ahead. Happy to answer.
Thank you, Nirmal, for that insightful session on video streaming and AWS Cloud. I unmuted all the participants. If you guys have any questions you want to ask Nirmal, you can unmute yourself and go ahead. You guys can also type in your questions if you want on the chat, and we can address them as well. Okay, Nirmal, I think everyone is okay with the session today. So thank you once again for taking the time to conduct that insightful session. And thank you everyone for joining on Tuesday afternoon for session 8 of the Podium. stay tuned for more. It'll be happening, having another tech talk again next month. Thank you, Nirmal.
Thank you, guys.
Thank you.